Across America, gardeners drag hoses through summer heat, run sprinklers that lose half their water to the air, and still watch their plants collapse by August. They buy water-storing crystals that break down in a season and drip lines that clog and need replacing. The watering never stops. But 4 simple tricks, using nothing more than buried wood, can build soil that stores and releases its own water for 20 years. Old-growth forests have done this for free for millions of years. The science is settled. Here are the 4 buried wood tricks they never put on a product label. Trick 1. The buried hardwood log core. The simplest and most powerful trick is also the oldest. You bury large diameter hardwood logs or whole stumps at the base of a raised bed, along the bottom of a trench, or directly beneath a new planting. Oak, maple, beech, and other dense hardwoods decompose slowly, and as they break down they turn into spongy, water-holding reservoirs that last 10 to 20 years and beyond. Roots and fungal threads grow toward that buried moisture and tap it through the driest weeks of the year. The reason it works for 2 decades is physical. A large log decays from the outside in, so it stores water and releases it gradually, instead of rotting away in a single season. The bigger the piece, the longer it lasts, and the wider the zone of moist soil it keeps around itself. But the wood you choose decides whether this works at all. Dense deciduous hardwoods like oak, maple, beech, birch, and apple are ideal because they hold their shape long enough to act as a reservoir while still softening into sponge. Avoid black walnut completely because it releases a compound called juglone that poisons tomatoes, peppers, and many other crops for years. Skip cedar, black locust, and other rot-resistant woods because they are built to resist decay and will sit in your bed like a sponge instead of turning into a sponge. And never bury painted, stained, or pressure-treated lumber because the preservatives that keep it from rotting are exactly the chemicals you do not want leaching around your roots. There is one catch to manage in the first year. As fresh wood begins to break down, the microbes doing the work pull nitrogen out of the surrounding soil, which can briefly starve shallow-rooted plants. The fix is simple. Bury the wood deep, at least 8 to 12 inches down, so that hungry zone stays below your root layer, and in the first season, plant nitrogen-fixing legumes like beans and peas, or add an extra dose of nitrogen on top. By the second year, the wood flips from taking nitrogen to releasing it. There is also a bonus most gardeners never expect. As the buried wood decomposes, it gives off a gentle, steady heat, warming the bed from below and stretching your growing season by days or weeks on either end of the year. The science is direct. In 2014, Goldin and Hutchinson published a study in the journal Soil Research measuring soil moisture at different distances from coarse wood. They found that drying times near the wood were 40% longer than in soil farther away, and that larger diameter pieces extended that effect over a greater distance. A 2016 undergraduate thesis at Western Kentucky University tested mounds built with buried wood, the classic Hugelkultur method, against flat control plots. Over 3 months of measurements, the wood-filled beds held nearly twice as much water as the bare control soil. To use it, dig down at least 1 to 2 feet, lay your largest logs across the bottom, and cover them with at least 8 to 12 inches of soil and compost. Use seasoned, untreated hardwood. You bury it once, and the bed keeps delivering stored water for as long as the wood takes to fully break down. Trick 2. The layered wood lasagna. A single buried log is good. A structured stack of mixed wood is better, and it solves the one mistake that ruins most buried wood beds. That mistake is leaving large air pockets. Big open gaps under the soil run out of oxygen. The trapped wood turns sour and slimy instead of spongy, and the whole bed eventually collapses into a sunken pit. The fix is to layer your wood by size and pack soil through every level as you build. Start with your largest logs on the bottom. Add a layer of branches on top of them. Then add a layer of smaller sticks and twigs. After each layer, shovel soil or compost into the gaps and tread it down so there are no large voids. Packing soil against the wood does more than prevent collapse. It presses decomposer fungi and bacteria into direct contact with every wood surface, so the whole structure breaks down evenly into one connected sponge rather than a few rotting logs surrounded by dead dirt. This spread of sizes is what gives the bed its lifespan. The twigs break down in the first year and feed your soil biology right away. The branches carry the next several years. The large logs are the long-term battery that keeps storing water for 2 decades. You are not building one reservoir. You are building a staggered chain of them that hand off to each other over time. A 2022 study by Dar and colleagues found that adding coarse woody debris to soil-raised water content and also moderated temperature, smoothing the swings between hot days and cold nights. That temperature buffering matters as much as the moisture, because it shields roots and soil microbes from the heat spikes that shut growth down in midsummer. Reclamation research, including work by Trepanier in 2022 on buried wood in constructed soils, confirms the pattern. Wood delivers its benefits when it is woven tightly into soil, not when it is dumped into hollow cavities. One thing to plan for. As all that wood decomposes, the bed will settle and sink over the first couple of years, so build it higher than your final target and simply top it up with compost as it drops. The sinking is not a failure. It is the wood quietly turning into the sponge you were after. Trick 3. The fungus-charged nurse log. This is where buried wood stops being a passive sponge and becomes an active water pump. The trick is to use logs that are already partly rotted, or to inoculate fresh logs with mycorrhizal fungi using a commercial inoculant or a few handfuls of soil from a healthy forest floor. You bury or half-bury the log so the fungi colonize the damp wood and then send their thread-like hyphae out through the soil to connect with your plant roots. The wood holds the water. The fungi move it. That partnership is what lets a single buried log keep plants alive through drought for years. The numbers are striking. Forest Service research in the Pacific Northwest documented that decaying down wood acts as a major moisture reservoir, especially through dry summer months. In one Southwest Oregon study, the mean moisture content inside decaying logs measured about 157%, which was 25 times higher than the roughly 6% moisture in the surrounding soil, and those logs were dense with mycorrhizal activity. The log was effectively a soaked battery sitting in dry ground. Then in 2022, Kakourides and colleagues published direct evidence in the journal New Phytologist that arbuscular mycorrhizal fungi physically transport water to plants. In their experiment, water moved across an air gap through fungal threads and accounted for 34.6% of the water the plants breathed out. Plants connected to the fungal network transpired almost twice as much as plants cut off from it. The fungi were carrying about a third of the plant's water straight from the moist wood to the roots. But there is a crucial detail that decides whether this works for your crops, and almost no one mentions it. Around 80% of plant families form these arbuscular partnerships, including tomatoes, peppers, squash, beans, corn, and most fruit. For those plants, a fungus-charged log becomes a private water line. The exceptions matter, though. Brassicas, which means cabbage, broccoli, kale, cauliflower, and radish, along with beets and spinach, do not form the partnership at all, and brassica roots actually release chemicals that suppress the fungi. For those beds, the buried log still works as a passive moisture sponge, but spending money on fungal inoculant is wasted. There is a second rule that protects the network. Tillage slices the fungal threads apart, so the less you dig and disturb the bed, the stronger the water pump grows over the years. To use it, source a log that is already soft and crumbling, or coat a fresh log with mycorrhizal inoculant before you bury it, and keep at least part of it touching your root zone. Skip the inoculant for brassica and beet beds. Because the fungal network rebuilds itself every season and resents being dug, this system gets stronger with time, not weaker. Trick 4. Ramial wood chips and biochar. The last trick fixes the one weakness of big buried logs, which is that a thick hardwood log takes years to start paying off. So you pair it with two fast-acting woody materials that work on completely different timescales. The first is ramial chipped wood. The name comes from the French word for a small branch, and it points to something specific. These are chips made only from young branches and twigs smaller than about 7 centimeters, or roughly 3 inches, across, taken from deciduous trees. This is not ordinary mulch. The concept was developed in the 1980s by Gilles Lemieux, a forestry researcher at Laval University in Quebec, who set out to copy how forest soil fertilizes itself. He found that the young branches of a tree, not the trunk, hold the living cambium layer where most of the tree's minerals and sugars are concentrated. That gives ramial wood a carbon-to-nitrogen ratio that fungi thrive on, roughly 40 to 170 parts carbon per part nitrogen, while trunkwood and sawdust run 400 to 1 or higher and end up stealing nitrogen from your soil. Deciduous branches matter specifically because the white rot fungi that colonize them convert their lignin into humic acids, the glue that builds long-lasting soil structure. Evergreen wood does not break down the same productive way. Layer ramial chips into the bed or spread them around your buried logs, and they set off a surge of fungal growth in the very first year. The second material is wood-derived biochar, which is wood burned slowly with almost no oxygen until only a porous carbon skeleton remains. Biochar is the long game taken to its limit. It is riddled with microscopic pores that grip water and dissolved nutrients, and unlike wood, it does not break down, staying stable in soil for centuries. There is one mistake to avoid. Raw, fresh biochar is so absorbent that it will pull nutrients out of your soil for the first season, so always charge it first by soaking it in compost tea, diluted worm-casting slurry, or liquid fertilizer before you bury it. Charged biochar hands nutrients to your plants. Raw biochar takes them. So the system now spans 3 timescales at once. The ramial chips work this season. The buried logs work for decades. The charged biochar works essentially forever. The science supports each piece. Lemieux's foundational work at Laval, confirmed in more recent studies including Darcy and colleagues in 2024, shows ramial chipped wood improves soil water, holding capacity, organic matter, and structure while feeding the fungal network. Decades of biochar research consistently show that wood-derived biochar sharply increases the soil's ability to hold water, thanks to its enormous internal surface area, while also improving nutrient retention. And broader work on woody amendments, including Lai and colleagues in 2018, confirms that adding woody material to soil makes more moisture available to plants. To use it, mix a layer of fresh ramial chips and a few handfuls of charged biochar in and around your buried logs. The chips feed the start. The biochar never leaves. But the method survived. While the watering industry kept selling hoses, timers, and gels designed to wear out, the knowledge of self-watering soil never actually disappeared. It just went unmarketed, because no one profits from a free log buried once and forgotten. Old-growth forests have run this system on their own for millions of years, dropping logs that quietly water the next generation of trees. German and Eastern European growers practiced Hugelkultur, literally hill culture, burying wood under their beds for generations before any researcher gave it a name. And over the last 2 decades, the science caught up. Forestry researchers measured the moisture locked inside decaying logs. Soil scientists at universities timed exactly how much slower wood-filled soil dries out. Plant biologists tracked water moving through fungal threads with isotope labels. Every study pointed the same direction the forest always had. The forest floor was the proof the whole time. You just have to bury it. So here is how to begin. If you are building a new raised bed, start with trick 1 and trick 2 together. Dig deep, lay your largest hardwood logs on the bottom, stack branches and sticks above them, and pack soil through every layer. If your area suffers real summer drought, add trick 3 by including a partly rotted log or a dose of mycorrhizal inoculant so the fungal pump is in place from the first day. Then finish with trick 4, working ramial wood chips and a few handfuls of charged biochar into the upper layers to feed the system immediately. Build it in autumn if you can, so winter rain and snow soak deep into the wood before your first growing season even starts. And the materials are often free. Storm-fallen branches, a neighbor's removed tree, arborist wood chips given away by the truckload. You bury it once, and the bed waters itself for the next 20 years. If this dug something loose for you, subscribe to Hank's gardening journey and ring the bell so the next one finds you. Every like and every share helps these methods reach the gardeners who need them. The next discovery is on its way.